Okay, so today we're going to recap on the security systems connections and basic operation, and we're going to take on some of the fire and surveillance basic operation. All right. Okay, so let's just, there we go. Fire security surveillance. Now, I'm not gonna watch that. I asked you to watch that last time. Hopefully you did. We did take a look at the main board. So just a quick recap on what this is. I'm going to go much quicker than last time. So AC, this is where the AC comes up, and it's about the doorbell transformer works pretty good with that. So it's about 18 volts AC. All right. Now, for this one, you can use the wire-in transformer, which is basically that doorbell transformer, and also there are available plug-in plug-in transformers. The wire-in, you mount it on the side of the electrical panel, and then you wire those wires, the primary windings, into the circuit breaker, and then you get the output on like screw terminals. The other one is a plug-in transformer, so it's just like a plug-in. You plug into the receptacle, and you get the screw terminals on the other end, providing you the AC voltage bell. That's where you connect the siren program. They work different with different security systems, so you gotta consult the manual or sometimes technical support. Basically, those turn in, and usually like this one's here, they once activated, it will connect to ground. All right, so 1, 2, 3, 4. Normally there will be floating, but different systems will have different configurations of those. So if you have some other thing connected to, let's say, plus terminal of the auxiliary input or the auxiliary output, then the other terminal of whatever device you have connected to the program, if the program is activated, is going to connect that to the ground. So you're going to have from the plus through the device to the ground. So it's just activating different types of devices based on whatever conditions you want to choose. Here's the common terminal. So common, they're all common. It's just like the, well, to complete the circuit for the zones. All right. Now, relay, dry contact relay, normally closed and normally open. So it's like a single pole double throw type of a dry contact relay. And dry contact means it's just floating in the air. It's not connected to anything. You can connect anything to it. It's going to act like a switch. So that's basically how relay works. Auxiliary, this is where you get where you power all the active devices from. So all the keypads, all the motion sensors, all the glass break detectors, anything, or expansion boards, they get the power from these two terminals, and we have 12 volts DC on that. Now, green and yellow, there's the bus connection. That's where the signal goes from some of the active devices, such as keypad. Now, the difference between the active device like a motion sensor and the active device like a keypad is that the motion sensor is going to need power from here, and that's it. And based on a condition like a motion, it is going to open or close a dry contact relay, and it's going to provide the information to the zone 1, 2, or whatever, 3, whatever zone. Okay, now as far as keypad, a keypad needs to communicate. It needs to have some sort of a data flow. And here is the bus terminal. So that means you can have more than one keypad, and those yellow and green wires from the Z4 wire, for example, and Z4 wire is basically red, black, green, and yellow. All right. Or red, green, and yellow and black, the old telephone POTS kind of a configuration, USOC configuration. All right, so the black and red usually are being used in alarm systems, are being usually used to connect the power to whatever device, and that's like a keypad. And you can connect multiple keypads tapping into that, so basically making a parallel connection from each keypad into that bus. And then there are different communication protocols that are using that bus line to communicate with each and individual keypad at the same, well, pretty much at the same time. All right, so common, again, here I have the zones, and these are the circuits. On zone 1, you can have just dry contact, door contact on the main door, for example, if you choose that. Zone 2, you can have all the living room windows connected in series. Zone 3, you can have garage doors, and so on. All right, so you can have 8 zones, but if you have 3 windows in the living room that open, you can put all 3 living room windows on one zone. So that's how you save the space as far as the zoning. Also, expansion boards are available. Here is the dialer, but this is the POTS dialer. So here we have ring and tip, and here we have ring and tip 1. The idea of the dialer, if you choose the POTS line, like a telephone line to monitor your system, you would connect the telephone line into the alarm system first before it gets anywhere else. So you're going to have to find a demarcation point in your house, for example, and disconnect your phone line from the whole house and connect it to this point right here first. And then grab it from here and reconnect it to the rest of the house. The idea is that when the system gets into alarm condition, if there is anyone using phone line at that time, or maybe the phone is not hung up properly, then it's going to take that line, hang up properly, look for the dial tone, dial out, communicate with the monitoring station, and then after the communication is going to hang up and release the line back to the rest of the house. All right. Now also we have one of the more important connectors. We have a serial port. That's where you can connect your serial interface from your laptop. That is connected to your laptop. So you got a serial interface connected to USB of your laptop, and the other part of the other side of the serial port is going to be connected to the serial port here. And then you can use that, the software designated for that particular main board to communicate and do the programming and setup. Because if you can program the whole thing from keypad, but it is just a long and treacherous process. With the laptop and the software, it becomes easy and more clear, and less confusing. The other things we're not going to talk about here. Now, here's the connection for the backup battery, and you see here's red and black. That's where we connect the battery. Now, we just went over those, and we have gone through. See here, that's how you connect the battery right here. There's a red terminal and a black terminal, positive and negative, and kaboom, that's where you connect things. There's also a fuse here that protects the circuit that has to do with the backup battery. Right? And it's just like a car, a lead acid battery right there. It's just made differently and smaller. So this main board is also a charger. It charges the battery, keeps the charge going, and when the power goes down, for example, you can have some time for some time that the system is still going to be operational. How long is it going to last? It depends on the number of the active devices and the activity within the system. So there is no set guarantee on how long this is going to last. But usually you would get anything from half an hour to an hour to 2 hours, maybe some 3 or 4 hours. Again, it depends on the number of active devices that you have connected to the system. All right. As far as the door contacts or the zoning, so these are connected to the zones. This is just a dry contact, door contact. It has a reed switch, just like the saxophone mouthpiece. It has a reed that vibrates. That's basically what it is. That's the shape of the switch that's inside here. You bring the magnet to it, the switch closes. You take the magnet away from that, the switch opens, and that goes to one of the zones of this. So here, usually we connect the green wire to the common and the yellow to the, but since it is a dry contact, really technically it makes no difference. But it's just a good idea to follow some sort of convention. So when you have multiple zones connected and multiple lines connected, it's easier to distinguish things from some things from other things. All right. No, these are the passive devices. And passive devices do not need to be powered to operate. Right? So we're not connecting the auxiliary power to it. Just don't need to. Now, sometimes you have just a closed loop with 0 ohms, well, close to 0 ohms, because there is still some resistance on the wires. So you're going to have a little bit depending on how long the line is. But it's, for the most part, it's considered a closed circuit. And sometimes you're going to have the end-of-line resistors, and the end-of-line resistors are mounted in series with that. So the system is going to, if it's programmed as an end-of-line loop, end-of-line resistor loop, is going to look for that resistance to be at ease. If there's something else than the resistance, it is going to trigger into whatever condition it is programmed to trigger that you want this thing to react. And usually what happens if it's disconnected, then it goes into a trouble. No, for the alarm system, yeah. If it's disconnected, then it's going to be alarm system. I'm skipping ahead of myself, thinking about the fire alarm system already, but no, this is the security alarms. All right, so here's the end-of-line resistor. Now, some boards can be programmed that you can connect 2 of those onto one zone. So you can have 2 separate zones. One is going to be closed loop, so 0 ohms, and the other one is going to be connected as the end-of-line resistor. So you have to tell the system to work that way, and in that way you can double the zones. I have never used that feature. I don't like that feature. However, it can be used. It's just, for me, it's just too, I don't want to use the word confusing, but it's making things more complicated than they need to be. Usually when I needed more zones, I would just purchase an expansion board and do it that way. Motion sensors, there you go. That's what things look inside. Now you have 1, 2, 3, 4, 5, 6 terminals, but look, here we're showing just 4. So here is the zone sensor, and here is the power. This provides the power to the electronic circuitry in that motion sensor. And based on the motion detection, the motion sensor can react. Okay. And it usually one of the most common ways of detection is the infrared, and the infrared field change. Like, for example, we humans, we do transmit certain infrared warrants around us, so that thing can see that, and it has to change in order for this thing. So if you're moving from one spot to another, that thing is going to sense it, and it's going to trigger into a alarm condition, which means it is going to open these 2. So at ease, these things are closed. Here's the zone. So these are the dry contact right here, normally closed, which means at ease it's closed. Some of them will have the screw terminal for normally open, but some of them will not even have that. It will just have the space on the printed circuit board, but there will not be a screw terminal. Now here's a temp. That's the temper switch. It's right here. That's the switch right here. There's also the cover has a little kind of a pusher there. When you put that thing in, it closes the switch. Excuse me. It closes that switch. So if somebody tries to take the cover, then the switch opens, and also the system can go into a alarm condition. You can wire that in series with this zone circuit here. Okay. All right. And for security alarms, normally it would be here's the zone, security alarm contact point. All right, security alarm contact point. All right. Acronym. See, that's the, when we just had the discussion about acronyms. I'm not in really favor of acronyms because, yeah, okay, if you have to remember 1 or 2 acronyms, that's fine. But if you're learning different subjects and everybody gives you like 25 acronyms, like, oh, come on, right? Yeah, suck. Yeah, okay. Well, all right, never mind. Zone. Here's the zone contact point. And you see, when you connect multiple sensors, you just connect them in series. Can you connect a motion sensor with the dark contact in series? Sure. You just connect the dry contacts, because these are dry contact. Those here, these contacts, it's a dry contact. So you can connect that in series with other things that are also dry contacts. And here is the zone loop. You connect one side to the common terminal, and the other side you connect it to any of the zones. You can choose zone 1, zone 2, and so on. All right. As far as wires, this is also a recap here. We're doing sensors. For the most part, will be motion sensors, glass break detectors, smoke, heat, water level detectors, seismic. These are the detectors that detect vibrations, usually mounted on safes in banks. Panic buttons. If there's a robbery somewhere, or at gunpoint or whatnot, there could be a hidden panic button. So you just press it with your foot or with your finger or something like that, whatever, and then triggers a silent alarm. But different different cities have different bylaws as far as using the panic buttons. So if you are a company that installs the security systems, you will have to consult the city that you are installing the system in and just find out what the laws and rules and regulations. You might not, so you might get through to the city, and it might take ages before you're patched through to a person that deals with that. But usually, when you contact any local alarm monitoring station, they will know the rules and regulations that apply to that specific city. So you might be quicker in finding information from them. And they could be wired or wireless, right? Annunciators, bell, siren, strobe. Okay, bell, which is a siren. Strobe light, sometimes both. Silent alarms, it could be silent alarms too. Client might want to choose not the alarm to be silent. If it triggers, it just makes the connection to the monitoring station and just does it that way. And if somebody breaks in there, they don't even know that the alarm was triggered. So that's the idea of a silent alarm. All right, so you can catch them. All right, there you go. Control. How do we control the system? Through keypads. You can program the system through the keypad that you use to arm and disarm. You can program this through a laptop, through IP, because some of the alarms are capable of connecting right to the network. And then you can connect your laptop not straight to the security system, so you don't even have to open the cover. You can just plug it into the network, and if you know the credentials, as far as if you have the credentials of the password and the IP address and all that stuff, yes, you can log in and you can program or access the system through the network or from outside. Very popular in some of remote areas, like the far areas like Yukon or other territories in Canada. Some of the distances are big, long. Well, the system can be 200 kilometers from where you are, or 100 kilometers from where you are. And if it's just some kind of a simple programming that you need to do, you don't need to drive there. You can access that remotely. Right? And there is the wireless remote control. That's more for like a user kind of control. You can arm or disarm the system using just like a remote control that can be in the form of a key fob, just like the car, remote control, about the same size. Quite useful thing. You can arm the system when you go to bed. Right? You can disarm. You can, if you pull into your driveway and you see something is not right, you're not sure if somebody is still in your house or not, then you use the remote control to arm the system, and if and if that person is still inside, they're going to move and trigger the alarm. So that's one of the better sales features. That kind of a story, not a story, but presenting that situation. It can be very real as well. Remember, alarm systems are installed so they can be used that one time, just like the brakes in your car. Usually, from my experience, when I was heavily involved in installing the security alarms, here is, and some people who are watching this may confirm this. You just mention you talk to someone, some of your friend or from your family or whatnot. So what do? I install alarms. Oh, we don't need it. I'm not trying to sell it to you. You asked me, so I answered the question. All right. And then what happens? Yeah, we don't need. And then 6 months later, someone breaks into their house, and then they're calling you, just, can you install that now? We need it now because we can't sleep. It's a usual story, right? So interfacing, the alarms can be interfaced with access control, and access control is another system that works really well, quite often in conjunction with the alarm systems. It's the swipe cards or key fobs to enter certain doors, to unlock the locks. They can be interfaced with the fire alarm. The security alarm and the fire alarm can feed off each other. And then, of course, we interface it with the monitoring station and other devices, who knows what. Cable, Z4, no twist. Remember, we're talking about that. There's no twist. So Z4, it's a no twist cable and uses that all pods configuration, which is, red and green and black and yellow. But when we use this thing in the alarm system, we usually use the black and red to connect the power to the active devices, and we use the yellow and green for the signal, which is basically open or close. Or it can be used as the data. The data is slow enough that it can travel through the untwisted pair. We don't want a twisted pair in alarm systems, because twisted pair also acts, it has some inductance, and if it has some inductance, it's going to act like an inductor, and inductors do not like change. They oppose sudden changes. The more sudden the change happens, the more it's opposed by an inductor. So if somebody opens and closes the door very fast, that signal might not even get through to the alarm system. So for that reason, you want to get untwisted. Can you get away with using, let's say, Cat5e? Yes, you can. But notice that you have 4 pairs. So instead of using each individual conductor for each pair, you just double the conductors on, let's say, blue pair, and you have 1 conductor made out of 2. And you double all the other ones, so you got blue, orange, green, and brown conductors. So then it's just like having 4 of those conductors, and those pairs are not twisted enough around each other that they can be considered as untwisted. So yes, you can get away with using those. All right, passive devices, active devices. Passive devices will be door contacts, window contacts, overhead garage contacts. They are specific. They have specific shape. So just take a look at Google that, please. Surface mount contacts or flash mount contacts. Surface mount is just go on the side of the door, the switch, and the magnet. And the flash contacts, they go inside the door frame, on the side of the frame. That will be the magnet of the door. And then on the inside of the frame of the door, there goes the actual contact with the wires in it, right? So that's called the flash. And when you close the door, or a patio door, they're very popular on patio doors, right? Or the modern type of windows. So you have the contacts there, but when the windows are closed, and even if they're open, you just don't even see them there, right? Active devices, keypads, expansion boards, motion sensors, glass break detectors, water sensors. Sunk pump water sensor is quite popular. Now, sensors, contacts. Let's just take a look at what I gave you in that link. I just clicked on that, and did anything happen? Oh, Here. All right. Here's a website, or just a link. There are different, see, some of them there's those with a rolling ball contacts as well. So you don't need a magnet. It's just like a rolling ball, and it's just being pushed inside when the door is closed. And when the door opens, it kind of gets out of the way, and it's, so that here is the flash door contact. All right. Here's the magnet part right here. And here is the switch that is activated based on the magnet. And of course, this switch part here goes on the door frame because you need to mount it on something that doesn't move because of the wires that are attached to it. And here's the magnet that's actually mounted right on the edge of the door. So when the door closes, those are aligned, and things are happening or not happening. I guess that's how these things work. Now, let's see. What do we have here? Glass break detectors. Did I get that? Click. Come on. Glass break sensors. They come in different shapes and sizes. Some of the wall-mounted glass break detectors are popular. Mounted close to the windows, and you might have to follow the manufacturer's instructions. There is another one here, and here is the burglar that tries to open the window with a crowbar. So that's how you open the window with a crowbar, kids. There you go. Some of them are mounted right on the glass. This will be the size of that. Some of the more popular ones would be it's somewhere down here. Oh, those here. Here is the sort of like a microphone part, the sensor part right here. So you point that somewhere on the hard surface. It could be ceiling, mounted on the ceiling, pointing at general directions of where the windows are. Excuse me. And it can sense it can act as a glass break detector. And remember, for the most part, those are made to get triggered when three things happen. There is that high pitch sound of the glass breaking, there is that low frequency rumble when the glass is just about to break, and there is a sudden pressure change, all happening in relatively close time, and so that then it is the glass break sensor is supposed to trigger. The reason for that is that if you have a cat at home and the cat just keeps walking, knocks over the glass on the floor, you don't want the alarm to trigger, because then you're going to have something like it's called false alarm, and false alarms are bad. In some cities, police give you one false alarm per year, and then you either have to pay money, or you're going to have to prove it to them that you have actually done something to improve the situation. You found the problem, and sometimes they just even stop responding. Now, very rarely like that, but yeah, it happens. So wherever you install the alarm systems, you always should consult the monitoring station and ask them about what the rules and regulations are. Like, for example, for a false alarm in the city that you are actually installing the alarm. Okay. Motion sensors. These are the fire alarms. Motion sensors. Yeah, you take a look at some of those. It's just to kind of give you some visual. So I give you this door contacts, glass break detectors, motion sensors, seismic. These are the detectors that sense the vibrations, and sump pump detect sensors. These are quite useful, because here's the thing: if you got a sump pump sensor, all right, and they come in different shapes and forms. Basically, that's what the sump pump is, and it's somewhere in the basement to get the groundwaters and to control the groundwaters so you don't get your basement flooded. And the sump pump is supposed to kick in when the water levels rise. Now, if the sump pump fails, you can have a double protection of a sensor. If the water rises above a certain level and the sump pump didn't kick in, it's going to close the contact. It's just like a contact, and it's going to be connected to one of the zones, and that zone can be programmed to be 24-hour zone. So whether the system is armed or not armed, if those sensors are triggered, the alarm is going to trigger, and something is going to happen, depending on so the alarm system can call you and let you know through your cell phone, or text you, or contact the monitoring station, and whatever the programming is of that. So quite useful thing. One thing that I didn't mention here is smoke detectors. Did I put some smoke detectors? I don't think I did. Smoke detectors and heat detectors. So sometimes the things that have to do with fire detection, they can also be connected to the security alarm sensor. So in some cases, in some commercial situations, and that depends on the city bylaws, depends on the inspector, so always contact the authorities. Some, like if you need some features of a fire alarm to be in your commercial facility, and let's say you have a security system and you want to just add some of the smoke detectors or heat detectors, usually it will be smoke detectors, and if that is going to be accepted by the city inspector as a sort of fire protection, then fine. Then you don't need to install and spend the money on installing the fire alarm. But then again, that depends on where you are, right? And the rules and regulations of where you are. Okay. Now let's take a look at some of the fire alarms. All right, fire alarms, as opposed to security alarms, very similar concept, but slightly different. All right, first of all, some heavy licensing, or very heavy. No, well, you need some additional licensing to be able to operate one of those. Not operate as a user, but operate as far as designing it, testing it, and troubleshooting it and servicing that. Right now, an installation as well. Basic for fire alarm, the types of sensor are a little bit more basic than the security alarms, but they can get a little bit more complex as far as that one type can have few different uses. Like, for example, a smoke detector. Could be a smoke detector you mount in the ceiling, or it could be a smoke detector for specific use that is mountable in the air ducts. So when there's a fire in the boiler room or whatever else, the smoke gets into the air ducts and it's not supposed to be there, then it's going to sense that. So there are different kinds of the same purpose, right? Detectors. But for the most part, you're going to have smoke detectors, heat detectors, and you're going to have some manually triggered devices such as the pull stations by the door. All right. So on this picture, we have main fire alarm panel, and we have the annunciators, and some of the annunciators, such as the strobe light and piezo sounders. It's like a little tiny speaker, but makes a little squealy noise that is supposed to be piercing your ears and cut through all kinds of noise. So some of them are, and in some of those things are being required the strobe light and a noise, right, of certain level, and the placement and the frequency of the placement and the distribution, it's all regulated. Right? And then we have detectors, smoke detectors, heat detectors, and whatnot. This thing can be interfaced to a telephone line, or it can be interfaced to the network as well, right, to communicate with the outside world. All right, some other sub panels can be connected to, depending on the brand and the manufacturer and the model number of whatever the security fire alarm is. You can have different brands and models of sub panels or annunciator panels and whatnot. All right, now how does the zone work in the fire alarm as opposed to the security alarm? Now remember, with security alarm, do we have that? No, we don't. With the security alarm, it was just a zone, so it would be a common point here, and there would be the sensing input. So there you would have one series closed loop, and if the loop opens, then that means it's alarm. Now with the fire alarm, it's a little bit different. Excuse me. You have the zone loop, and it is terminated with something that's called end of line resistor. End of line resistor, and usually it's quite often it's 47 kilo ohms, but this might vary depending on the model number and manufacturer of the alarm system. Now, that end of line resistor is what it says, nomen omen. The name defines the purpose. End of line. It should be at the end of the line. Okay. Is the system going to work if you take that resistor and place it right at the terminals, at the panel? Yes, the system is going to work, but it's not going to work properly. The purpose of the end-of-line resistor is that, well, to tell the system that when it sees that resistance, then the system is at ease and there are no broken lines along the way. That line can be broken, can be interrupted. If you put that end-of-line resistor at the terminal, and if the line is broken, the system is not going to know. So then if there's any sensors are being triggered, it might not be functional, and the system will never know that the line is broken. So it should be at the end of line. It's called end of line resistor. There is a reason why I'm saying that. It's because, never mind. All right, now, as opposed to security alarm, when the system is closed loop and system opens, triggers alarm, it's the opposite. All the sensors are normally open. When they trigger, they close. So what happens here? We have different conditions. If the line is broken, then the system is not going to see, the zone is not going to see the end of line resistor, and it's going to go into a trouble condition. And trouble condition is just sending a bunch of annoying beeps from the panel that somebody's going to get up and check what's going on, and it's going to say, trouble, call so-and-so for service. All right. So then they're going to call for service, and services, people are going to come and find out what's going on. Usually there's some kind of a line broken or ground broken or something like that. Now, that's the trouble condition. It's not a fire alarm condition. Now, if one of those sensors closes, instead of seeing an open loop, which is infinite resistance, that thing is going to see a closed loop, which is zero resistance or close to zero, and then it is going to trigger into alarm condition. Okay? So that's how the zones work for the fire alarms. Sensors, basically heat, smoke, or manual, such as pull stations. Annunciators, bell, siren, or strobe. Interfacing. They can be interfaced with security alarm. So security alarm and the fire alarm can feed off each other, but it has to be done according to the rules and regulations that apply to the area that you're in. So always consult. Monitoring station is the best source to do that. Interfacing with the monitoring. Fire alarms can be interfaced with sprinkler systems, and usually they are. If the sprinkler system is triggered, Then it also has a direct contact, and it opens or closes depending on the programming. And it can be connected to one of the zones of the fire alarm or the security alarm. They are interfaced with PA systems. Commercial buildings should have PA systems that can be used to enunciate hazard hazard conditions. So let's say fire. This is not a whatever, this is not a drill. Please leave the building right now. Or this is a drill. Please go. This was a drill. Please go back to your office or something like that, right? So PA systems are mandatory in most of the areas. Okay. Kitchen fire suppressions. This is almost like a topic on its own. This would be the hoods over the gas stoves or wherever the gas heat and flame is, and sometimes they are mandatory to install, and these are called kitchen fire suppressions. It's a whole system that has heat sensors on top at the hood, and if the heat gets too much, the sensor reacts. Basically, it's like a line that can be burned through, and it opens, and it manually triggers the fire suppression system. So it sends the signal to the fire alarm. That's one thing, and it also triggers a extinguishing, like a huge fire extinguisher that is going to extinguish the fire, and then it's going to pour water on it so the fire doesn't restart. It's just to cool down the heating elements and so on. But it's almost like a science of its own. All right. And here's my favorite: others. Okay, there we go. Control. How do we control the fire alarm? How this fire alarm is being controlled? Well, fire alarm panel, as far as the main operation, you can trigger with a laptop, or control it with a laptop, and through IP network and remote access control. Now, electrical code in effect, fire code in effect, licensing involved. If you're interested, talk to me. I'll put you through the right department in our college. If you want to pursue a career in fire alarms systems and things that have to do with that. Okay. Fire alarm cabling, fire alarm cable, unshielded, and usually they are red jacketing. Okay. Fire alarm cable, shielded, armored fire alarm cable, and fire alarm cable armored with a foil shield. So they are different, but notice one thing is that they are red. Okay? Some of them are not. Now, from the fire alarms, let's take a look at some of the security surveillance. Right? Basically, it's the cameras. All right, that's what a typical security surveillance camera looks like. It's a dome type of camera. All right, so the security cameras, they kind of go back a little bit. Right? It used to be that there was a camera that needed power to be supplied to it from a separate cable, and there will be another, usually a coaxial type of cable, connected to the output of that to get the video. Now, long story short, things have developed a little bit different. Now we have something that's called IP cameras. So the camera does have IP address. It's a smart device. It does have IP address. And look, there's an Ethernet connection right there. There's also a power input, but sometimes it's not even used because the camera also has an option of being powered through, remember, PoE, it says power over Ethernet. PoE. But there's an option. Excuse me. Right? All right. Now, here is a typical example of something that's called NVR or DVR. What's the difference between NVR and DVR? Right now, at this day and age, there's not much difference. One stands for digital video recorder, and the other acronym stands for network video recorder. And these are for security cameras. Before DVR existed, there was something that's called TDR, with the letter T as in tango, and D as in delta, recorder. TDR, and there will be time domain recorders. And that involved a VHS tape, mostly VHS tape. If somebody doesn't know what VHS tape is, sad thing for me to say, Google it, all right? Sad, why is it sad? Because it makes me feel old. All right, never mind. Okay, and so the TDRs used to work in a way that they used to work on time division. So you would put in the VHS tape into the TDR, and the channels, let's say it had, the TDR was capable of connecting 16 cameras. So the TDR would cycle through, would multiplex the time allocations to each camera, and it would cycle very fast. Well, relatively fast. So if you wanted to look at a picture just from one camera, the TDR would align its receiving heads and display to just the times that camera one was recording. And in that case, the motion would look somewhat strobe-y, right? Like a strobe-like motion because of that fast cycling. So that was the TDR. Then after that, the cameras that were being used for that would be just video cameras, security video cameras, and they would have power provided to it by a separate cable and a signal by usually a coaxial cable. Also, something that was developed, something was called Siamese cable, that would consider that would be like a one cable containing two vanes for the power and a coaxial cable. Then the DVR was developed. Things went digital. And it was same thing, except you didn't use the videotapes. Because the problem with the videotapes was that somebody had to replace the tapes all the time. And the security system, the security room would have a stack of tapes. And the tapes would be named Monday, Tuesday, Wednesday, and so on. So you would just cycle through the tapes. So the video recorded on one tape would last maybe a week, or however you decided. Then you have to buy more tapes. The digital video recorder, well, it would cycle through. It could be programmed so it cycles through. And depending on the quality that you choose to be recorded, then you can decide how long do you want to keep that. But there's a compromise. You get the length of the recorded material, so you can make it so it lasts 2 weeks or even a month, but there will be at the cost of the quality of recorded video. When you are purchasing the NVRs or DVRs or video surveillance systems, don't look at the quality of the picture of the live display, because it was always going to be nice, crystal clear, and it's going to be razor blade sharp. It's nice. You can see the colors, you can see people's faces, you can see all that stuff. Look at the recorded image. If you want buying it, ask them to show you how is it that the image looks like when it's recorded and played back. Then things are slightly different, right? Depending on the quality. You get what you pay for, for things like that. And why do you need that? It's basic so you can view the recording images, not to see how pretty the picture is when it's live. Yeah, cars are driving by and squirrels are jumping up and down. Right? Right? So then the network video recorder can be connected to a network, so you can access it through the LAN, local area network. Excuse me. And you can also access that through like remotely. However, pretty much all the DVRs are capable of network connections, so there's not much difference between NVRs and DVRs anymore, right? So, and you will hear that acronym being used interchangeably. Now, how do you connect the cameras? You can connect the cameras directly into the DVR or NVR. These are the ports. So you can see this one here is capable of 1, 2, 3, 4, 5, 6, 7, 8 cameras. And here's the network connection. And look, here's the VGA output. Here's the HDMI output. Well, you can record the sound as well. And there are other controls. There's a serial port even on this one here. Look, there's a USB. If you want to extract some of the video, and you can program, okay, I want a video from Tuesday on camera 7 between the hours of 10 o'clock a.m. and maybe 1 p.m., right? So then you're going to prepare that onto the hard drive and you're going to extract that onto USB. You can do that and give it to the police. Quite often when you install these cameras on some commercial buildings, sometimes you get visits from the police because something happened in the area and they're just trying to see if there's anything that your cameras have caught, any of that situation. Yeah, it's a common thing. All right, now, when you connect that, usually when you connect it that way, direct camera connection, the NVR or DVR is going to sense the cameras and there's very little additional setup required. But you can do something else. You can do it this way. Let me explain what we can see here. Here is the main, let's say here is the main frame for the surveillance system. But you could have longer distances inside the building. So you could sub it. You could subdivide it. Look, these 3 cameras, or it could be more, are connected to this switch. And the switch is connected to the main frame. Then these cameras are connected to this switch, and this switch is connected to the main frame. And so you get the idea. Right? But now, when you do that, the switch is connected to the main network. Right? Very rarely you're going to have the switch connection to that. So when the camera is connected to the NVR or DVR, the device doesn't know that the camera is connected, and it has to be told to look for the camera with the IP number. And it's going to be, you can program the camera to be seen by that. So you have to enter the camera's IP number into the main system, so it recognizes that. So when there's a signal that, so they do the handshake and they communicate with each other. So this, and so on. So every camera has to be programmed in to the system as opposed to just a direct connection. And sometimes with a bigger system, that's the only way to solve the longer distances, because you're not going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wires. And sometimes those NVRs or DVRs, they don't have enough ports. So they have capability of servicing 50 cameras, 24 cameras, right? 32 cameras. But they don't have those direct ports. They just have one Ethernet port or maybe 2, and that's how things are being solved. Right? Secure topology, well, it would be star most of the time, right? There you go, typical surveillance system with a digital video recorder and remote off-site viewing. Okay, so here is the NVR. Here is the viewing area here. And it can be connected to Ethernet or internet or both. So it can be accessed through your laptop, through your tablet, through your cell phone, and whatnot. These are it's nothing unusual these days. Right? Secure surveillance. Cabling, well, right now, Cat5e minimum, for the new installed systems and new installed for some time. But some of the older ones, and these are still in existence, you're going to find that there are two separate cables going there, one for the power and one for the signal. Some of the distributors will still sell. They will still sell the older equipment that is capable of the video being plugged in. The video is being plugged in with the coaxial cable, and you have some separate power supplies to power up those cameras. And the reason why they still sell that is because you will still see, well, it's becoming more rare as time goes by, but still there will be some systems that are working perfectly fine, not as much resolution as some of the new ones, but if the client is happy with it, hey, the client is the one who signs the paycheck. And the head end has gone bad. So you just want to retrofit the head end, just to retrofit the main recording device and keep the old infrastructure of the cameras. Sometimes clients want to do that. So yes, it is still possible to get some of the older configuration of the system. So then you would use the coaxial cable and you would use the Ethernet cable. And if it's the Ethernet cable, for the most part, you're going to use the PoE, power over Ethernet. So the switches are supposed to have PoE capability. Some of the switches have just a signal on their Ethernet ports. Some of them are capable of injecting the power over Ethernet. All right. Okay, so this is as far as the basic concepts of the security we just kind of reviewed. And there's the fire alarm. And there is the surveillance, video surveillance system. Just so you know, when you leave the school and you have opportunities to apply to different companies that service different type of equipment, at least you know something about it. And then the rest is going to be for the rest, you're going to apply your knowledge that you learned in the other subjects like practical soldering, AC/DC theory, and whatnot, and your programming skills. And then you're going to combine that with the knowledge that is going to be given to you by the manufacturers of the equipment, because every equipment is made and set up to work slightly different. They're different from each other. So you're going to have to know how to program this, that, and the other thing. But with this one here, you have at least a good starting point. The other type of systems would be sound systems. That's one thing. The other thing would be nurse call systems. Nurse call systems are sometimes they're referred to as the call bells. It's the buttons by the bed. Okay, so time is gone by. You guys have to go to other classes, and I will see you when I see you next time. Remember, we have to all the labs have to be done, performed, and evaluated, and you have to have a passing mark for those labs in order to pass the course. So do not miss that. Right now, until the end of the week 14. There is open lab sessions, and it is posted. The details are posted in the announcements. Don't miss your labs. And of course, if there's anything else that you want to talk to me about, by all means, send me an email or talk to me during or after the class. Thank you, guys. Have a good Easter weekend. Bye.